Hello, welcome back to Sleep Science. Tonight, we are going somewhere very few people have thought carefully about. Not to a star, not to a black hole, not somewhere violent or strange or hard to picture, just to a planet in our own solar system, and to the most beautiful thing orbiting it. Right now, at this exact moment, as you lie there, as the room settles around you and the day starts to let go, billions of pieces of ice are moving through space in perfect silence. Each one in its own orbit, each one alone. Some are the size of a house, some are the size of a car, some are no bigger than the tip of your finger, some are smaller than a grain of sand, some you couldn't even see with your naked eye, tiny fragments of frost drifting in the dark. But all of them are moving, and all of them are completely, absolutely silent. They have been doing this for a very long time, longer possibly than you might expect. We will get to that. But right now, just know that they are there. Right now, tonight, a little over 1 billion miles from where you are lying, Saturn's rings are exactly as they always are. Patient, still in their motion, undisturbed, going about their slow, ancient business in the dark, with no one watching, needing no one to watch. And tonight, we are going there. There is no rush. We have all the time you need. Let me tell you something about Saturn first, because it helps to know what you are circling before you go in. Saturn is the 6th planet from the Sun. It sits out past Jupiter, past the asteroid belt, past everything close and familiar. If the Earth were the size of a grape, Saturn would be roughly the size of a basketball. That is not a perfect comparison, but it gives you a sense of the proportion. It is large, genuinely, almost incomprehensibly large, in the way that most things in space are large, which is to say that the numbers stop meaning much, and you have to reach for something else. The diameter of Saturn, through its middle, is about 9.5 times the diameter of Earth. If you could somehow hollow it out and pour Earths in, you would need somewhere around 760 of them to fill it. And yet, despite all of that volume, despite being that vast, Saturn is the least dense planet in the solar system. It is made mostly of hydrogen and helium, gas all the way down, or nearly so. The density is so low that if you could find an ocean big enough, Saturn would float. It would sit on the surface of that impossibly enormous ocean and just float there. Which is one of those facts that sounds made up and isn't. Distance is the thing that is hardest to feel, though. Saturn is, on average, about 9.5 times farther from the Sun than Earth is. Earth sits about 93 million miles from the Sun, so Saturn sits roughly 886 million miles away, closer to 1 billion. The light that leaves the Sun takes about 8 minutes to reach us. It takes roughly 80 minutes to reach Saturn. If you were to get in a car and drive to Saturn at highway speed without stopping, never sleeping, just driving, it would take roughly 10,000 years to get there. You would not make it in a lifetime. You would not make it in 10 lifetimes. The Voyager 1 spacecraft, launched in 1977, moving at roughly 35,000 miles per hour, took about 3 years and 2 months to reach Saturn. 3 years of traveling faster than any human being has ever traveled, and it still took 3 years. That is where the rings are, that far away, and still visible from Earth with the naked eye if you know where to look. Just a steady, yellowish point of light in the night sky, unremarkable unless you know what it is. Point a modest telescope at it, and the rings appear, tilted at whatever angle they happen to be at. A tiny oval of light around a tiny bright sphere, and it stops you. It stops most people. Galileo was stopped by it. In 1610, he pointed one of the earliest telescopes at Saturn and saw something that confused him so profoundly, he wrote it down as a question rather than a description. His telescope was not good enough to resolve the rings into what they actually were. They looked like two lumps on either side of the planet. He wrote to a colleague and described Saturn as appearing to have two companions, one on each side, almost like ears. Ears. He thought the planet had ears. He called it the three-bodied planet, actually, because what he saw looked like three things close together. And then, 2 years later, he looked again and the ears were gone. The rings had tilted edge on to Earth, which happens periodically, and from that angle they essentially disappear because they are so thin. He wrote that he didn't know what to say, that it seemed as though Saturn had swallowed its children. He never figured it out. Galileo died in 1642, not knowing what he had seen. It was a Dutch astronomer named Christian Huygens who worked it out in 1655, using a better telescope, describing Saturn as surrounded by a thin, flat ring inclined to the ecliptic. He got it essentially right. A ring, surrounding the planet, flat, thin. The first person to understand what that light actually was. And what it actually was, we now know in extraordinary detail. The rings are made mostly of water ice. That is the thing that surprises people when they hear it for the first time, even people who already know it. Water ice. The same stuff that forms on the inside of your freezer if you let it go too long. The same stuff as a frozen lake in January. Ordinary water, frozen into particles of every size, drifting in orbit around a gas giant 1 billion miles away. About 90 to 95% of the rings, by mass, is water ice. The rest is rock. Silicates and carbon compounds, the dark, dusty material that coats some of the particles, the stuff that makes some parts of the rings look darker than others. There is a little bit of organic material mixed in, a little dust, but mostly, overwhelmingly, ice. And the particles range enormously in size. This is something worth sitting with for a moment. The rings are not one thing. They are not a uniform field of pebbles, or a sheet of glass, or a smooth disk. They are a population of individual objects, each one its own little body, each one in its own orbit. And the range of sizes within that population is extraordinary. At the small end, there are particles of dust, micron-sized fragments, things you would need a microscope to see, drifting in the outer diffuse rings. In the main rings, the typical particle is somewhere between a centimeter and several meters across. So most of them are about the size of a small rock, a marble, a fist, up to something about as big as a large boulder. And then, at the large end, scattered through the rings, there are objects that could be house-sized, maybe larger. Not many of them, but they are there. Ice. All of it ice. Tumbling slowly in the dark. Now, the thing that takes your breath away, the thing that makes the rings genuinely one of the most strange and specific objects in the solar system, is how thin they are relative to how wide they are. The rings stretch outward from Saturn for a distance of roughly 280,000 kilometers. That is more than twice the distance from the Earth to the Moon. Wider than you can quite picture, a disk of ice and rock stretching out into space in every direction from the planet, immense, overwhelming in scale. And the average thickness of that disk, through the main rings, is somewhere between 10 meters and 1 kilometer. Think about that ratio. If you were to shrink the rings down to the size of a piece of paper, scaling everything proportionally, the rings would be thinner than the paper. In fact, they would be far thinner than the paper. The rings are, proportionally, about as thin as the thinnest layer of paint you could spread on a surface. They look solid from a distance. They look like a physical object, a flat disk, something you could land on, the way a planet has a surface. But they are not solid. They are a collection of individual particles, mostly separated by meaningful distances, each in its own orbit, and the total amount of material in all of Saturn's rings combined is surprisingly modest. If you gathered all the ring material together, compressed it into a single sphere of ice, that sphere would be roughly 100 kilometers across. Just 100 kilometers. Less than the distance across a small state. All of it. All that extraordinary wide, flat ring system. Condensed, it would fit inside a sphere you could fly across in a few minutes. Which is strange when you think about it. All that appearance of substance. All that beautiful, sweeping width. And at its core, just a modest amount of water ice, spread out thin. How did the rings form? This is a question that astronomers have been asking for a long time, and the honest answer is that nobody knows for certain. There are theories, good theories, well-supported theories, but the rings have not fully given up the story of their origin, and that is one of the things that makes them quietly compelling. The oldest and most widely held theory for most of the 20th century was that the rings were primordial, that they formed at the same time as Saturn itself, about 4.5 billion years ago, from the same cloud of gas and dust that formed the planet, and that they had simply been there ever since, unchanged, patient. This is a satisfying idea. Ancient rings, rings as old as the solar system. But there are problems with it. One of them is the color. The rings, particularly the innermost main rings, are remarkably bright. They are some of the most reflective objects in the solar system, and what gives them that brightness is the purity of the ice. Old ice, ice that has been sitting in space for 4.5 billion years, should not be that pure. Space is not clean. There is constant rain of micrometeorites, dust, dark carbonaceous material from comets, the general debris of the solar system. Over time, over billions of years, all of that material should have darkened the ice, coated it, made it grey and dull. The brightness of the rings suggests they are much younger than that, possibly only a few 100 million years old, maybe less. And a few 100 million years ago, the dinosaurs were walking around on Earth. It is possible, and this is a strange thought, that when the dinosaurs were alive, Saturn had no rings, or different rings, or rings that were barely beginning. The rings that Galileo saw with his telescope, the rings that Cassini mapped, the rings that exist tonight as you lie there, may be a relatively recent addition to the solar system, which makes us extraordinarily lucky to exist at the same time they do. But where did they come from? One leading theory is that a moon of Saturn, possibly a large one, was destabilized somehow, gravitationally, or struck by something, and broken apart. The debris from that shattered moon spread out into the orbital plane around Saturn and became the rings. The ice from the moon's interior, the clean, young ice, the pristine stuff, became the bright ring particles we see today. A moon died and became something more beautiful than it was. Another theory is that Saturn captured a comet, or a large icy body that wandered too close, came inside what is called the Roche limit, which is the distance from a planet at which tidal forces become so strong they tear a body apart, rather than letting it hold together. And the comet, or the icy body, came inside that limit and was ripped apart by Saturn's gravity, and the pieces became the rings. There is a third possibility, less dramatic. Some of the ring material may simply be leftover debris from Saturn's own formation. material that never quite came together into a moon, that has been orbiting Saturn in some form for a very long time, but perhaps rearranged and refreshed by later events. Most scientists now lean toward the relatively young rings hypothesis. The pristine ice, the brightness, the way certain structures in the rings look dynamically active rather than ancient and settled. The rings feel young, a few 100 million years old at most. Some estimates push as low as 10 to 100 million years. But the debate continues. The Cassini mission gave us extraordinary amounts of data, and that data has sharpened the question rather than fully answered it. We know more about the rings than anyone has ever known, and we still do not know exactly where they came from. Some things remain patient in their mystery. Let's move through the rings themselves now, because the rings are not one ring. They are a whole family of rings, each one with its own character, its own density, its own width, its own particular strangeness. They have been given letter names, which is a little plain for something so extraordinary, but the names are old, and they stuck. And moving outward from Saturn, they go D, C, B, A, F, G, E. The D ring is the innermost. It sits just above the cloud tops of Saturn, barely separated from the atmosphere itself, a thin and wispy thing, not bright, not dense. If you were to fly through it, you would barely notice. It is made of fine dust, faint and tenuous, the kind of ring that you could only discover from space, because from Earth it was invisible. Voyager 1 found it in 1980. The D-ring is not where the drama is, but it is where the rings begin. Moving outward, you reach the C-ring. The C-ring is also called the crepe ring, which is an older name and a nicer one. It is relatively broad, stretching across about 17,500 kilometers of space, but it is not very dense, not very reflective. Translucent, almost. You can see Saturn through it if you are at the right angle. It has some structure within it, some variations in density, some ringlets and gaps, but it is subtle, quiet. The kind of ring that takes careful observation to appreciate. The C ring contains a few interesting structures. There are narrow ringlets within it that are surprisingly sharp-edged for something orbiting in essentially empty space. There are slight color variations. There is dark material mixed in with the ice. It is not pristine. And then you reach the B ring, and everything changes. The B ring is the brightest part of Saturn's ring system. It is also the widest of the main rings, about 25,500 kilometers across. That is roughly twice the diameter of the Earth, just this one ring. And it is dense. Genuinely, solidly dense compared to the rings on either side of it. So dense that Saturn's light cannot get through it in many places. Opaque, or nearly opaque. And it is bright. The B ring is where most of the mass is, where the ice is thickest and purest, where the ring system is doing most of its work. It has enormous structures within it, wave patterns and clumps and variations that take hours to trace from one end to the other. Cassini found that the B ring has regions of dramatically different density side by side, which was puzzling, which suggested that the ring has some kind of internal organization that we do not fully understand. There are spokes in the B ring. This is something Voyager discovered and Cassini confirmed. Radial, wheel-spoke-like features that appear in the B ring and then disappear. Features that extend from near the inner edge of the ring outward. Dark structures that rotate around Saturn approximately with the planet's magnetic field rather than with orbital mechanics. Which should not be possible. Objects orbiting a planet do not all rotate at the same rate, because the inner ones orbit faster and the outer ones orbit slower, and anything that was organized radially should shear out into a curve very quickly. But these spokes don't shear, or they shear slowly, or new ones form as old ones fade. The exact mechanism is still not fully settled. It involves charged dust particles being lifted off the ring plane by electrostatic forces, held in place temporarily by the magnetic field, and then dropping back down. Saturn's magnetic field is involved, the plasma environment. And the spokes are seasonal, more prominent when Saturn is near equinox. There is so much in that one ring to think about, but the B ring ends at a gap. The Cassini division. It is named for the Italian-French astronomer Giovanni Cassini, who discovered it in 1675. A gap in the rings, visible from Earth, a dark band separating the B ring from the A ring. Wide enough that early observers thought it might be a true gap, empty space, a hole in the ring system. The Cassini division is about 4,800 kilometers wide. That is nearly as wide as the United States from coast to coast. From Earth, it looks black, empty, like space itself is showing through. And it mostly is. There is some material in the Cassini division. Cassini, the spacecraft, flew through it and found that it is not entirely empty, that there are faint ringlets there, thin populations of particles. But it is orders of magnitude less dense than the rings on either side, and what created it is something genuinely elegant: gravity and timing. There is a moon of Saturn called Mimas, small moon, about 400 kilometers across, famously crater-marked, the kind of moon that looks almost comically scarred. Mimas orbits Saturn outside the main rings, at a distance that puts it in what is called a 2-to-1 orbital resonance with the Cassini division. Orbital resonance is one of the more beautiful ideas in celestial mechanics. What it means is that particles at a certain distance from Saturn complete exactly 2 orbits in the time it takes Mimas to complete one. So twice in every Mimas orbit, those particles receive a gravitational nudge from Mimas, always at the same point in their orbit, always pushing in the same direction. The nudges are tiny, but they accumulate. Over time, over thousands and millions of orbits, those accumulated nudges add up, and particles at that distance get pushed outward, away from that resonant location. And what was once a populated region of the ring becomes thin. Mimas swept out the Cassini division by gravitational resonance, without even meaning to, without being aware of anything, just by existing, just by orbiting, just by having gravity. Mimas cleared a gap in the rings 4,800 kilometers wide that is visible from Earth with a telescope. There is something satisfying about that, the tidiness of it, the way order emerges from pure physical law, no plan, no intention, just the patient arithmetic of gravity repeated billions of times until a feature appears. The Cassini division looks like absence, but it is actually a story about presence, about Mimas out there in its own orbit, keeping its own schedule, creating emptiness by being exactly where it is. On the other side of the Cassini division is the A ring. The A ring is the outermost of the main bright rings. It is about 14,600 kilometers wide, narrower than the B ring, and it is bright and dense, though not as dense as the B ring. It has its own gap within it, the Encke gap, about 325 kilometers wide, and within that gap a small moon named Pan orbits, keeping the gap clear in much the same way that Mimas keeps the Cassini division clear, though through a different mechanism. Pan is tiny, maybe 28 kilometers across at its widest, but it is enough. Pan is one of the stranger-looking moons in the solar system. It has an equatorial ridge, a belt of ring material that has accumulated around its middle, giving it a flying saucer shape, a ravioli shape, depending on how you look at it. Material from the surrounding ring has piled up around its equator as it orbits through the Encke Gap. It looks absurd, a tiny, flying saucer-shaped moon, keeping a 325-kilometer gap in a ring clear, moving through that gap silently in the dark. The A-ring also contains the Keeler Gap, only about 42 kilometers wide, maintained by another small moon, Daphnis. Daphnis, even smaller than Pan, has its own equatorial ridge, and as it orbits through the Keeler Gap, the edges of the gap are ruffled and wavy, because Daphnis's gravity pulls the ring particles on either side upward and downward as it passes, creating a wave pattern that Cassini imaged in extraordinary detail. A tiny moon, 8 kilometers across, raising waves in a ring of ice. At the outer edge of the A-ring, there is a structure called the Encke minima, and, more interestingly, the outer edge of the A-ring is itself kept sharp by a moon, Atlas. Atlas orbits just outside the A-ring's outer edge and helps define it, a shepherd moon for the ring as a whole. Beyond the A-ring, moving outward from Saturn, there is a narrow gap, and then the F-ring. The F-ring is unlike the others. It is narrow, only a few hundred kilometers wide in its brightest parts. It sits just outside the A-ring, separated from it by a gap called the Roche division. And it is dynamic in a way that the other rings are not. Visibly, observably dynamic on timescales of days and weeks, not millions of years. The F-ring has structure within it that twists and braids. It has clumps that appear and disappear. It has strands that wind around each other and then unwind. It has channels carved through it, dark gaps that appear when something passes through and then slowly fill back in. All of this is because of two shepherd moons, Prometheus and Pandora. Prometheus orbits just inside the F-ring, and Pandora orbits just outside it. They are both small, lumpy, irregular bodies, potato-shaped, maybe 80 to 100 kilometers across at their longest dimension. Neither of them would win any awards for beauty in the conventional sense. They look like tumbling rocks. But between them, they keep the F-ring in existence. Without them, the material in the F-ring would spread out, diffuse, lose its coherence. The ring needs to be herded, kept together, and Prometheus and Pandora do that herding. Prometheus is the more active of the two. Its orbit is slightly eccentric, slightly non-circular, which means that on each orbit it gets closer to the F-ring at one point and farther away at another. And every time it gets close, its gravity reaches into the ring and pulls, creating streamers of ring material that flow toward it and then snap back. Cassini watched this happening. Cassini imaged the streamers. Cassini caught Prometheus pulling dark channels through the bright F-ring material, channels that take several orbits to fill back in before Prometheus comes around again and makes new ones. Channels look deliberate. They look like something moving through tall grass, leaving a path. But they are just gravity. Just the mathematics of masses moving near each other. Prometheus does not know it is doing this. It just orbits, and the ring responds, and has been responding for however long these moons have been in their current configuration. Something about that is very peaceful. Moving further outward from the F-ring, the rings get thinner and more diffuse. There is a broad region between the F-ring and the G-ring that contains little material. The G-ring itself is thin and faint, a narrow band about 8,000 kilometers wide, maintained partially by a small moon called Aegeon, a tiny object embedded within the ring, a few hundred meters across. And then the E-ring. The E-ring is the outermost of Saturn's named rings. It is also the most unusual in terms of what it is made of and where its material comes from. The E-ring is enormous, extending from the orbit of Mimas all the way out past the orbit of Titan, millions of kilometers. But it is extremely faint and diffuse, not a bright structure like the inner rings, but more of a cloud, a haze of fine icy particles spread across an enormous region of space. And the source of the E-ring material is, of all things, a moon. Enceladus. Enceladus is a small moon of Saturn, about 500 kilometers across, and it has geysers. Active cryovolcanic geysers, plumes of water vapor and ice particles erupting from cracks in its south polar region, spraying material upward and outward into space. Those ice particles, ejected from the geysers, spread through the orbital region of Enceladus and become the E-ring. The E-ring is being continuously replenished by Enceladus's geysers. It is being born, right now, as you lie there. Ice particles erupting from a small moon and drifting out into Saturn's orbital space to join the ring that Enceladus has been feeding for however long those geysers have been active. There is warm water under the ice of Enceladus, possibly an ocean. Possibly a liquid water ocean, kilometers deep, heated by tidal forces from Saturn, and possibly by hydrothermal vents on the ocean floor. Cassini flew through the plumes of Enceladus and tasted them, found water vapor, ice particles, organic compounds. Enceladus might have life. Small microbial life, maybe. Nothing certain. But the chemistry is there, the warmth is there, the liquid water is there, and the ice from that possibly inhabited moon, the ice from those geysers rising above a possible ocean, drifts out into Saturn's rings and becomes part of the E-ring, which floats there now, tonight, impossibly faint, impossibly wide, in the dark. It is worth stopping here for a moment, just to sit with the scale of what we have been describing. From the innermost D-ring to the outermost edge of the E-ring, Saturn's ring system spans a distance of roughly 480,000 kilometers. That is more than the distance from the Earth to the Moon. All of that, ring material in some form, spread across that distance, orbiting Saturn. The bright main rings, the ones Galileo saw, the ones Huygens described, the B-ring and A-ring and C-ring, and the Cassini division. Those span about 65,000 kilometers on their own. But even they, all that light and ice and brightness, are proportionally paper-thin. A sheet of ice 65,000 kilometers wide and maybe 100 meters thick. That is the core of what we call Saturn's rings. And somehow knowing that right now, as you lie there, those billions of ice particles are moving through silence a billion miles away, each one in its own orbit, each one alone, keeping the same path it has kept for possibly millions of years, makes the room feel impossibly still. This room, right now. Everything's stopped and quiet, while out there, in the deep cold of the outer solar system, lit by a sun that looks no bigger than a bright star, the rings move. Patient, silent, unchanged. Now, the particles themselves. You are floating in the rings. Just for a moment, just to understand what it would actually be like, imagine yourself suspended in the ring plane, somewhere in the A-ring, just an observer, weightless, drifting slowly along with everything around you. The first thing you would notice is that the rings do not look like they do from Earth. From Earth, or from a photograph taken from outside the ring plane, the rings look like a solid disk, a beautiful flat structure, banded and bright. From inside the ring plane, from within the rings themselves, it is different. You are surrounded by ice, not a wall of ice, not a dense cloud, but individual particles, each one visible, each one moving. Most of them are moving at almost exactly the same speed as you, which is why they appear to float. Orbital mechanics means that everything at roughly the same distance from Saturn orbits at roughly the same speed. So relative to you, relative to your position in the ring plane, the particles around you are nearly still. Some of them drift slowly, almost imperceptibly. The ones slightly closer to Saturn are moving just a fraction faster and gradually pulling ahead. The ones slightly farther out are moving just a fraction slower and gradually falling behind. But the effect from inside is one of suspension, of stillness within motion. The particles catch the light. Saturn's sunlight, which out there is weaker than it is here, weaker by the square of the distance, but still light, still real. The ice particles scatter that light. They sparkle. Each one is a small, imperfect crystal, tumbling slowly on its own axis, catching the light at different angles as it rotates. They are not all the same. Some are smooth spheres. Some are irregular, faceted, many-sided, catching light the way a rough diamond catches light. Some are coated with a thin layer of dark material, which makes them look greyish, like dirty snow. Some are pristine white. Some are faintly blue-white, which is what pure ice looks like. Some of them are large enough that you could land on them, stand on them in your spacesuit, reach out and touch their frozen surfaces. And all of them moving in absolute silence. There is no sound, not the whoosh of particles passing, not the crack of occasional collisions. Nothing. Space has no medium for sound to travel through, no air, no gas, nothing for a pressure wave to move through. The particles collide occasionally, gently, these slow-speed collisions that happen in the ring plane, as particles on slightly different orbits gradually drift into each other. But even those collisions are silent. You would see a particle tumble and change direction. You would see two chunks of ice tap together and slowly drift apart, and you would hear none of it. Absolute silence. The kind of silence that has no texture. Not quiet, exactly. Not the quiet of a room late at night, where you can still hear the hum of electronics and the distant sound of the world going about its business. This is the absence of sound as a physical property of the environment. Not just a lack of noise, but the impossibility of noise. Around you, in every direction, ice particles moving in the dark. Below you, filling your entire lower field of vision, Saturn. Saturn from inside the rings is something no human being has ever seen with their own eyes. It would be immense, genuinely, physically overwhelming in scale. If you were somewhere in the middle of the main rings, Saturn would fill roughly the same portion of your visual field as the wall of a room fills when you are standing close to it. It would not look like a planet in the sky. It would look like a world below you, a surface, a curved horizon in every direction. The cloud bands would be visible, the pale gold and cream and faint amber stripes of Saturn's atmosphere, the wind patterns, the vast weather systems. Saturn has the second fastest winds in the solar system, up to about 1,800 kilometers per hour in some regions, faster than any wind that has ever blown on Earth. But from the rings, you would see none of that speed, none of that violence. Just a vast, gently striped golden sphere filling the sky below you. And from that distance, it looks as still as everything else. The shadow of the rings themselves falls on Saturn's atmosphere, a dark band cutting across the cloud tops, moving slowly as Saturn rotates. Saturn rotates quickly, about once every 10.5 hours, and that shadow sweeps across the planet with it. Above you, through the ring plane, through the scattered ice particles around you, you can see space. Stars. But fewer stars than you would see from open space, because the ring particles above you scatter and absorb some of the starlight. It is not completely blocked, but it is filtered, softened. The sky above you is faintly milky with scattered light, and at certain angles, certain positions in the ring plane, the light through the rings is extraordinary. When the sun is low relative to the ring plane, near equinox, the ice particles catch the light in a way that makes the rings glow. Not just reflect, but genuinely glow, each particle lit from the side, the light diffracting and scattering and producing halos and coronas around the sun. The rings become a plane of light, a flat galaxy of softly glowing ice, stretching to the horizon in every direction. No noise, no weight, just light and ice, and the enormous gold planet below you. The rings are moving, of course. You are moving too, orbiting Saturn at whatever orbital speed corresponds to your distance from the planet. In the middle of the A ring, that is roughly 16 kilometers per second. 16 kilometers every second. Roughly 35,000 miles per hour. But you cannot feel it. There is no wind, no acceleration. You are in free fall, in the technical sense, meaning that you are in orbit, which means gravity is accelerating you continuously towards Saturn, and your velocity is constantly redirected so that you keep missing it. Free fall feels like weightlessness. Free fall feels like floating. Free fall feels like nothing. So you drift, surrounded by ice, above Saturn, moving at 16 kilometers per second through the dark, feeling nothing, hearing nothing, seeing everything. There is something about that combination, the stillness of the experience, combined with the reality of the speed, that is hard to reconcile. You would be moving faster than any spacecraft ever built by human hands has moved for sustained periods, and it would feel like complete rest, like lying in a dark room, still, at 35,000 miles per hour. The rings have a sound, or rather, scientists have given them a sound, because the rings themselves are silent, and that is fine and appropriate. But human ears are curious things, and we wanted to hear what the rings would say if they could say anything. NASA and researchers working with Cassini data have produced what they call data sonifications, which is exactly what it sounds like. You take the data, the measurements of particle density and ring structure and wave patterns, and you map those measurements to musical parameters. Higher density becomes higher pitch, or more volume, or a different timbre. Wave patterns become rhythms. The result, when you listen to it, is strange and beautiful and slightly eerie. The B ring, with all its density variations and internal structures, produces a kind of low, complex drone with shifting harmonics. The wave patterns produce a rhythm that emerges and fades. The ring edges have a particular sound, a transition, a change in character. None of it is real, in the sense that the rings themselves are silent. But all of it is data. All of it is information about the actual physical structure of the rings, translated into a form that human ears can engage with. It sounds, when you hear it, a little like ambient music. Like something made in a recording studio by someone with a fondness for very long, slow sounds. Patient sounds. Ancient sounds. It sounds, weirdly, a little like sleep. The structure within the rings is not random. You can look at the rings from outside, carefully, with a good telescope or with Cassini's cameras, and you see structure everywhere. Ringlets, gaps, density waves, waves at the edges of rings, clumps, braids. Almost all of this structure comes from gravity. From the gravitational interactions between ring particles and Saturn, between ring particles and the moons, between ring particles and each other. Gravity at every scale, gravity between tiny ice particles, gravity from moons hundreds of kilometers away, gravity from Saturn itself. The density waves are particularly elegant. When a moon orbits outside the rings in a resonant relationship with particles at a certain ring radius, the repeated gravitational nudges from the moon create a spiral wave pattern in the ring density, a wave that propagates outward through the ring material like a ripple in still water. Except the ripple is in the density of orbiting ice particles, and it spirals because the ring is rotating. So you get a spiral pattern, like a galaxy arm, written in the density of the ring. Cassini imaged these density waves in extraordinary detail. They look like grooves in a vinyl record, tight, regular, endlessly repeating, each groove a crest of slightly higher particle density, each gap between them a trough of slightly lower density, and they spiral outward from the resonance location, getting more closely spaced as they go, carrying information about the mass and orbit of a distant moon, written in ice. A message, almost, written in the ring by the gravity of a moon that doesn't know it is writing anything. All of these structures, all of these waves and gaps and ringlets and braided rings, all of this organization and complexity was mostly invisible to us until spacecraft went there. From Earth, from the surface of this planet, you can see the rings. You can distinguish the main ring system from the Cassini division. With a very good telescope and perfect seeing conditions, you can begin to see the banding, the difference between the A ring and the B ring. But the detail, the extraordinary fine-grained structure that Cassini revealed, was beyond us. The Voyager missions, Voyager 1 in 1980 and Voyager 2 in 1981, were the first spacecraft to give us close images of the rings, and those images were a shock. Everyone thought the rings were relatively simple, maybe a few dozen ringlets at most, and Voyager revealed hundreds, thousands. The ring system was far more complex than anyone had imagined. And then came Cassini. Cassini was launched in 1997. It took 7 years to reach Saturn, using gravity assists from Venus, Earth, and Jupiter to build up enough speed. It arrived at Saturn in July 2004 and inserted itself into orbit. And then it spent the next 13 years circling the planet, studying it, imaging it, tasting it, mapping it. 13 years. Think about what was happening on Earth in 2004. Think about everything that changed. Cassini was out there, circling Saturn, sending data back the whole time. It sent back over 400,000 images. It discovered 6 new moons of Saturn. It discovered that Enceladus had geysers. It discovered liquid methane lakes on Titan. It told us more about Saturn's rings than everything we had ever learned before it, combined. And then, in 2017, it was time to end. The reason Cassini had to end was fuel. The spacecraft was running low on the propellant needed to maintain its orbit, to make the small corrections that kept it on its planned trajectory. When that fuel runs out, you can no longer control where the spacecraft goes. And the concern was that if Cassini were to simply drift into one of Saturn's moons, particularly Titan or Enceladus, with their potential for liquid water and possibly life, it might contaminate those environments with Earth microbes. Organisms that had survived the launch and the journey and 13 years in the outer solar system. Organisms that might be alive when the spacecraft crashed. So the decision was made to end Cassini deliberately, in a way that would both prevent contamination and gather as much science as possible in the process. They called it the grand finale. In the final months of its mission, Cassini flew a series of ring-grazing orbits, dipping inside the F-ring, closer to the main rings than it had ever been, tasting the material of the rings directly. And then it flew 22 dives, 22 orbits that took it between the innermost D-ring and the cloud tops of Saturn itself, through a gap of roughly 2,000 kilometers, traveling at roughly 70,000 miles per hour through that gap. 2,000 kilometers sounds like a lot, but relative to the scale of everything else, it is not much. Cassini was threading a needle, fitting through a narrow space between a planet and its rings at tremendous speed, over and over again, each time gathering data that had never been gathered before. What was the density of the material between the rings and the planet? Was there a sharp boundary? What did the magnetic field look like up close? What was in the gap? The answers came back, orbit by orbit. The gap was cleaner than expected. Very little material. The ring particles had not drifted inward into that space as much as some models predicted. The magnetic field was almost perfectly aligned with Saturn's rotation axis, which was strange because magnetic fields are usually at least slightly tilted, and the near-perfect alignment made it harder to measure the planet's rotation rate. Data. More data. Different data than anyone expected. Data that raised as many questions as it answered. And then, on September 15, 2017, Cassini made its final dive. Not between the rings and the planet this time, into the planet. Cassini flew directly into Saturn's atmosphere. The last day of Cassini. In the final hours, the spacecraft was oriented so that its antenna pointed toward Earth, so that the data it was gathering could be sent back in real time. It was measuring atmospheric composition, temperature, pressure, taking readings of the atmosphere as it descended, as the gas around it got thicker and the drag increased. The signal took roughly 83 minutes to travel from Saturn to Earth at the speed of light. Cassini hit Saturn's atmosphere and the drag began to build. The spacecraft started to tumble. It had thrusters and it fired them, trying to keep itself stable, trying to keep the antenna pointed at Earth, trying to keep transmitting. But the atmosphere was winning. At 7:55 in the morning, Pacific time, on September 15, 2017, Cassini's signal was lost. The spacecraft itself had ceased to exist several minutes before that, 83 light minutes before that. By the time the signal loss registered on Earth, Cassini had already been gone for an hour and 23 minutes. It had already been torn apart by the atmosphere. It had already scattered its atoms through Saturn's cloud layer. It had already become part of the planet. At the Jet Propulsion Laboratory in Pasadena, the team had gathered. People who had spent 20 years, some of them, building this spacecraft, preparing it, flying it, studying the data it sent back. People who had spent more of their adult working lives on Cassini than on anything else. People who knew this spacecraft in a way that is hard to describe without sounding strange, knew its systems, knew its quirks, knew what it could and could not do, knew it the way you know a thing you have taken care of for a very long time. When the signal dropped, some of them cried. Not because it was a failure. It was not a failure. It was a perfect, planned, deliberate end. It was Cassini doing exactly what it was designed to do, even at the very end. Even in its last minutes, with the atmosphere thickening around it and the drag building, it was taking measurements, it was sending data, it was doing science. But still. The signal dropped and something that had been there for 20 years was not there anymore. The project manager, Earl Mays, stood up in front of the team and said something to the effect of, You should be incredibly proud. This was a mission without precedent. And it is not really goodbye, because Cassini is part of Saturn now. It is there. It is still there. Cassini is part of Saturn. A human-made spacecraft, built on Earth, launched from Earth, flying for 7 years and then circling and exploring for 13 more, and now part of the clouds of Saturn. Its atoms mixed with Saturn's atoms. Its material dissolved into the planet it spent over a decade studying. There is something about that. The rings were still there when the signal dropped. The rings were still moving. The shepherd moons were still at their work. Prometheus was still pulling its slow, patient channels through the F ring. The B ring's spokes were still appearing and fading in the sunlight. Enceladus was still erupting, still feeding the E ring with its icy plumes. None of it noticed. None of it changed. The rings are patient in a way that makes human timescales feel very small. 20 years of work, and the rings were there when the work began, and there when it ended, and they were not changed by any of it. But we were changed by it. We know what we know because of Cassini. We know the rings in the way we know them because a spacecraft spent 13 years in Saturn's orbit and sent back 400,000 images and endless streams of data, and eventually gave its body to the planet. What we know about the rings, we know because someone built a thing and sent it there and asked it to look and tell us what it saw. And it did. For 13 years it did. The shepherd moons do not only keep the rings in their shapes, they also shape the edges of the rings in ways that are still being understood. The outer edge of the B ring, for instance, is maintained in a roughly circular shape by the orbital resonance with Mimas, the same resonance that keeps the Cassini division clear. But the edge itself is not perfectly smooth. It has waves in it, vertical waves, where the ring material piles up slightly and then flattens, creating structures that stand up above the ring plane. Cassini measured some of these vertical structures at the edge of the B ring and found that they were standing up to 2 kilometers above the ring plane. Towering ice structures in ring plane terms. The ring plane is only tens of meters thick in most places, and at the edges, in these wave structures, material is piled 2 kilometers high. They look, in Cassini's images, like mountain ranges. Ridge lines of ice catching the sunlight, casting long shadows across the ring plane below them, because the sun is low relative to the ring plane near equinox, and the shadows are very long. Mountains in the rings, 2 kilometers tall, built by gravitational waves, illuminated by a sun that from there looks no bigger than a very bright star. And then they subside, and the ring goes flat again, and the mountains are gone. This happens on timescales of hours, these slow waves passing through the ring edge, raising ridges and then lowering them, the way a wave in the ocean raises water and then lowers it, except the wave here is moving through orbiting ice particles, and the ocean is 1 billion miles away from the nearest shore. There is a thing called ring rain. It was known theoretically for some time, but Cassini confirmed it, measured it, gave us numbers. The rings are not staying. They are, very slowly, draining into Saturn. Charged particles in the rings, ice particles that pick up an electric charge from ultraviolet light or from Saturn's plasma environment, those particles get pulled along Saturn's magnetic field lines, and the field lines connect the ring plane to Saturn's upper atmosphere. The charged ring particles flow down the field lines, like water down a pipe, and fall into Saturn's atmosphere. This is ring rain, and the rate of it is significant. Not visible on human timescales, not even visible on historical timescales. But over millions of years, the rate of ring rain is enough to drain the rings of a meaningful fraction of their mass. At current rates, the rings could completely drain into Saturn in somewhere between 100 million and 300 million years. Some estimates are shorter, some longer. But the direction is clear. The rings are temporary, which changes everything about what they are, slightly. They are not an eternal feature of the solar system. They are not permanent. They arrived at some point, relatively recently in geological and cosmic time, and they are leaving. They will be gone before the sun runs out of fuel, before the Earth becomes unlivable, long before the universe does whatever the universe eventually does. They have a lifespan, a beginning and an end. And right now we are in the middle of it. We exist at what might be the peak. The rings are here, mature, bright, extraordinary. In 100 million years, they might be a thin ghost of what they are now. In 300 million years, they might be gone entirely. And every night, right now, they are out there, still bright, still patient, still exactly what they are. The particles in the rings have their own individual stories in a way. Each one formed somewhere, somehow. Maybe it was part of a moon once, a chunk of ice broken off in a collision billions of years ago. Maybe it is a droplet of water that was once part of an internal ocean, a droplet that was flung outward by a geological event and froze and has been orbiting ever since. Maybe it is a piece of a comet that strayed too close to Saturn and was torn apart by tidal forces, its body scattered across the orbital plane. Whatever its history, it has been in this orbit, more or less, for a very long time. And it is now, tonight, moving through space at several kilometers per second in absolute silence, with no awareness of any of it. Not aware of Saturn below it, not aware of the other particles around it, not aware of the shepherd moons nudging its orbit, not aware of Cassini having sailed through this exact region of space just a few years ago, not aware of you, lying here in the dark, thinking about it. It just orbits, that is all. That is the whole of its existence, and it is enough. It is more than enough. It is a complete existence. One ice particle, in one orbit, in the dark, for millions of years. There is something about that kind of patience, that kind of stillness in motion, that is hard to find anywhere else in human experience. We move, we change, we want things and get them and want new things. We make plans that turn into different plans. We worry about time. And out there, a billion miles away, an ice particle that has not done anything but orbit, that has not needed to do anything but orbit, that will keep orbiting until ring rain takes it, or a gravitational perturbation nudges it into a new path, or it drifts slowly towards Saturn over millions of years, just orbiting, silent in the dark, surrounded by billions of others doing exactly the same thing, and has been doing so since before the first human being lit the first fire, since before the first tree, since before the first fish pulled itself onto land and learned the feel of air. That is how long some of this ice has been exactly where it is, keeping its orbit, not moving toward anything, not moving away from anything, just moving around, which, in the middle of a night, when the mind is quiet enough to receive that thought without arguing with it, feels like permission to simply be somewhere, to simply exist in one place without needing to become anything else. The Cassini division. We talked about how it looks, how it appears from Earth, that dark band, that gap you can see with a decent telescope on a clear night. We talked about how it got its name, Giovanni Cassini, 1675, a man who looked at Saturn through a telescope and noticed an emptiness in the rings and wrote it down. But what it actually is, what the physics of it actually means, takes a moment to settle into. The particles that used to be in the Cassini division are not gone from the universe. They were pushed outward, gradually, orbit by orbit, resonant nudge by resonant nudge, the particles that once orbited at that distance were destabilized, their orbits perturbed, and they migrated. Some moved outward into the A ring, some moved inward into the B ring. The division is not a place where matter was destroyed. It is a place where matter was relocated by the patient, persistent mathematics of orbital mechanics. Mimas did not clear the Cassini division in a moment, or in a year, or in a million years probably. It took tens of millions of years at least of gravitational nudging, each nudge tiny, each one adding to the ones before, and eventually the region emptied. An emptiness that took tens of millions of years of mathematics to create, and which is now, from Earth, visible as a dark line in a bright ring. The universe is patient in a way that makes patience feel almost like a physical law, not a virtue, not something you choose, just the operating condition of everything that exists on long timescales. Things happen on the timescales they happen on, and the rings do not hurry, and the resonances do not hurry, and the emptiness of the Cassini division did not arrive until it was ready to arrive, and then it was there, and it has been there ever since. The orbital resonance that creates the Cassini division is a 2-to-1 resonance with Mimas, meaning that for every one orbit of Mimas, particles at that resonant location complete exactly 2 orbits. The numbers line up perfectly, and that perfect lining up is what concentrates the gravitational nudges. But there are other resonances throughout the ring system. The ring system is threaded with them. Almost every gap, almost every ringlet edge, almost every sharp feature in the rings corresponds to a resonance with one of Saturn's moons. The Huygens gap, at the inner edge of the Cassini division, corresponds to a 2-to-1 resonance with Mimas. The outer edge of the B ring is maintained by the same resonance. The outer edge of the A ring corresponds to a 7-to-6 resonance with the moon Janus. 7 orbits of the ring particle to 6 orbits of Janus. Perfectly synchronized. The mathematics keeping a ring edge sharp in space. And what is remarkable about this is not that it happens, because the physics is clear and well understood, but how it feels. That a moon hundreds of thousands of kilometers away from a ring particle, a moon that is simply doing what moons do, which is orbit, can keep a ring edge sharp over millions of years through the patient accumulation of small gravitational influences. The rings are, in a sense, a record of every gravitational relationship in the Saturn system. Every moon leaves its signature. The mass, the orbit, the resonant distances, all of it is encoded in the structure of the rings, in the gaps and edges and waves, if you know how to read it. Cassini read it. The grand finale. We should spend some time here because it deserves it. The decision to end Cassini was made years before the end. It was planned, deliberate, thought through. And the plan was not just to crash the spacecraft somewhere convenient. The plan was to do science right up to the last possible moment, to use the final fuel reserves to get Cassini places it had never been able to go before, to gather data that could never be gathered from further out. The ring-grazing orbits came first. In late 2016, Cassini began flying orbits that took it through the outer edges of the ring system, skimming past the F-ring, sampling the material at the outer edges of the rings. Dust analyzers ran. Magnetometers ran. Cameras imaged the rings from angles and distances that had never been possible before. Then came the 22 grand finale dives, between Saturn and the D-ring, the innermost gap, the place where the planet ends, where its atmosphere fades into the ring material above. Cassini flew through that gap 22 times, at roughly 70,000 miles per hour, each orbit taking about 6.5 days, each dive gathering a different kind of data or testing a different hypothesis. The team at JPL had to do something they had never done before. They had to point Cassini's high-gain antenna forward, like a shield, because in that region between the rings and the planet, they were not sure how much material was present, how much dust, how many particles. The antenna, a 4-meter dish of aluminum and beryllium, would protect the spacecraft's instruments from particle impacts. They were not sure if it would work. The first dive was a held breath, and Cassini came through it. Through the gap, through whatever dust and particles were there, and emerged on the other side transmitting normally. The antenna having done its job, the spacecraft intact. Then they did it 21 more times. Each time, closer measurements of Saturn's magnetic field, closer measurements of the atmosphere, closer sampling of the material between the rings and the planet. The data came back, orbit by orbit, and the scientists analyzed it. The gap was cleaner than expected. The models had predicted more material between the rings and the planet, more charged particles, more dust. What Cassini found was a relatively clean gap, with less material than the models suggested, which was itself data, which refined the models. And the magnetic field, perfectly, almost impossibly aligned with Saturn's rotation axis. This was genuinely puzzling. A planet's magnetic field is generated by motion in the planet's interior, by rotating conducting fluid, by dynamics that are inherently messy and asymmetric. Almost every planet with a magnetic field has that field tilted relative to the rotation axis. Earth's magnetic field is tilted. Jupiter's is tilted. Saturn's is almost perfectly aligned. The tilt is less than 0.06 degrees. Why? Nobody knows for certain. There are theories involving a layer of stably stratified helium rain deep in the Saturn's interior that might be smoothing out the field, averaging out the asymmetries. But it is not fully resolved. Saturn kept that secret even at the end. On September 14, 2017, the night before the final plunge, the team at JPL held a small gathering. Not a party, not exactly. Just people together. People who had spent decades on this mission, being together in the place where they had spent those decades. Scientists tend to be reserved about emotional expression, publicly. There is a cultural bias in science toward the objective, the measured, the reproducible. Feelings are not measurements. Feelings do not go in the data record. But feelings were present that night. These were people who, in some cases, had devoted the most productive years of their professional lives to this mission. People who had been graduate students when Cassini launched, and who were now senior scientists with their own graduate students. People who had been in their 50s when the mission began, and were now old. People who had shaped their careers around the data that this spacecraft had sent back, who had based their reputations and their research programs on Cassini's findings, who had published hundreds of papers using Cassini data. And tomorrow, all of that was ending. Not because the mission had failed, because it had succeeded completely, far beyond initial expectations, and it had used its fuel, and it was time to go. September 15th, 2017. In the early hours of the morning, Pacific time, Cassini made its final orbit adjustment, pointing itself towards Saturn's atmosphere. The final sequences were uploaded, the final commands sent. The spacecraft turned its instruments outward and began its last measurements. As it descended into Saturn's atmosphere, it sampled the air. The mass spectrometer, one of Cassini's key instruments, was tasting the atmosphere directly for the first time, not sampling it from hundreds of kilometers above, but from inside it, with the gas itself flowing into the instrument. Water, carbon dioxide, molecular hydrogen, helium. The building blocks of the outer solar system, present in Saturn's cloud layer exactly as the models had predicted. and also with some surprises in the ratios, some patterns that would take years of analysis to fully understand. The spacecraft was tumbling now. The atmosphere was thick enough that the drag was overwhelming the attitude thrusters. Cassini was trying to keep its antenna pointed at Earth, trying to keep transmitting, but the atmosphere was stronger. 7:55 a.m. Pacific time. The signal stopped. At the Jet Propulsion Laboratory in Pasadena, in the control room where they had received Cassini's transmissions for 13 years, the last data point came in, and then there was nothing. The radio telescope dishes in Australia that were receiving the signal heard it stop midstream. One moment it was there, carrying data from the edge of Saturn's atmosphere, and then it was gone. The people in the room were quiet. Some of them put their faces in their hands. Some of them stood up and applauded. A standing ovation for a spacecraft, for 13 years of extraordinary science, for a mission that had changed everything they knew about the Saturn system. Some of them did both, applauding with tears running down their faces. The project manager said, "I'm going to call this the end of mission." And then he paused and said, "I hope you're all deeply proud of what we've accomplished here, because I certainly am." And then Cassini was Saturn's. It had been a spacecraft for 20 years. It would be a cloud of atoms in Saturn's atmosphere for the rest of Saturn's existence. The carbon and silicon and aluminum and beryllium that had been shaped by human hands in a clean room in California was now mixing with the hydrogen and helium of a planet 1.3 billion kilometers away. There is something about that transition, something that is genuinely hard to categorize. Not sad exactly, not happy exactly. Something else. Something that sits between the two and does not quite resolve. The mission was complete. The data was in. The knowledge was ours, all of it. Every orbit's worth of images and measurements and samples. Cassini had given us everything it had to give. And in giving everything, it had become part of the planet. On Sleep Science, we occasionally take these long journeys not to arrive anywhere in particular, but just to be somewhere else for a while, to be in a different place, quieter and stranger, and further from whatever the day brought. Saturn's rings are one of the better destinations for that kind of journey, because the rings do not ask anything of you. They are not dramatic. They are not threatening. They are just there. Beautiful, patient, silent, doing their slow work. And knowing that they are out there right now, that as you lie here in the dark, the exact same rings that Cassini photographed, the exact same ice particles that Galileo's telescope first confused for ears, are still moving, still orbiting, still being exactly what they are, makes the night feel very full somehow. Full of things that need no explanation, full of patience. Let's stay in the rings for a while longer. You are still there, floating in the A-ring. The ice particles around you, tumbling slowly in the dim sunlight. Saturn filling the sky below. And now it is worth looking more carefully at a single particle. Just one. Pick one. The one closest to you, maybe. About the size of a large grapefruit, slightly irregular in shape, faceted, like a rough-cut gem. Its surface is mostly white, slightly bluish in the cold, direct sunlight, with patches of grey where dust has accumulated over time. Small pits on its surface from micrometeorite impacts, tiny craters no bigger than a pinhole. The surface is not smooth. It is grazed and marked by millions of years of minor impacts. It is rotating slowly, not spinning fast, not dramatically tumbling, just rotating. Maybe one revolution every few minutes. Catching the light differently as it turns. Bright when a facet faces the sun, darker when a shadow falls across it. And it is orbiting Saturn, right now. continuously. The same orbit it has been keeping, more or less, for possibly hundreds of millions of years. It has been around Saturn more times than there are grains of sand on every beach on Earth. More times than there are words in every book ever written. And it has never arrived anywhere. It just goes around. The particle does not know it is beautiful. It does not know that from certain angles, in certain lighting conditions, it catches the sunlight and scatters it in a way that makes it look like a small jewel. It does not know that Cassini imaged countless particles like it. It does not know that human beings have looked at photographs of the rings and felt something. It is ice. Water ice, roughly, with some contaminants. A structure of hydrogen and oxygen atoms arranged in a crystal lattice, frozen solid at somewhere around -185 degrees Celsius. A temperature so cold that the concept of warming it becomes almost abstract. And it is moving through the universe at roughly 16 kilometers per second. And it feels no movement and hears no sound, and it simply is. Which is, when you let it settle, one of the more peaceful facts you can hold in your mind before sleep. The shepherd moons. We touched on Prometheus and Pandora when we were talking about the F-ring, but it is worth spending more time with them because they are genuinely strange and interesting objects, and because the work they do is something that was not fully understood until spacecraft went there. Prometheus is about 136 kilometers long and 79 kilometers wide. It is not a sphere. Almost none of Saturn's small moons are spheres. To become spherical, a moon needs enough mass for its own gravity to overcome the rigidity of rock and ice and pull everything into the lowest energy shape, which is a sphere. Small moons do not have enough mass for that. They are whatever shape they happen to be when they formed, or whatever shape remained after the collisions and accretions of their early history. Prometheus is lumpy, elongated, roughly potato-shaped with some irregularity. It has craters, it has ridges. It is not beautiful in the way that a smooth, round moon might be called beautiful. But it is interesting in the way that unusual things are interesting. And it is doing something extraordinary. As Prometheus orbits just inside the F-ring, the eccentricity of its orbit means it periodically gets slightly closer to the ring and then slightly farther away. When it is close, the gravitational pull of this small, lumpy, 136-kilometer potato reaches into the ring and pulls at the particles. Not strongly. The force is tiny. But it is there. And the effect, which Cassini imaged repeatedly, is a streamer. A thin tendril of ring material drawn out of the F-ring toward Prometheus, extending from the ring toward the moon, and then, as the moon moves on in its orbit, snapping back, the material falling back toward the ring. Not exactly, though. Not quite back to where it started. There is a slight offset, a slight change, a slight disturbance left in the ring where the streamer was. A dark channel, a lane where the particle density is slightly lower than it was before. Over time, over many orbits, these channels accumulate in the F-ring. The ring bears the marks of Prometheus's repeated passages, the way a beach bears the marks of waves. Regular patterns, channels at regular intervals, the geometry set by the relationship between Prometheus's orbital period and the ring's orbital period. When Cassini first imaged these channels in detail, they looked almost artificial. Too regular, too structured, too much like something deliberate. But they are entirely the product of orbital mechanics, of gravity and timing, of a small moon orbiting near a thin ring, and the mathematics insisting that this is what must happen. Pandora, orbiting just outside the F-ring, acts as a counterbalance. Where Prometheus pulls ring material inward, Pandora's influence tends to push it outward. Together, they constrain the ring, keep it from spreading, maintain its narrow width. They are a pair, Prometheus and Pandora, though they are very different in character. Pandora is smaller, about 104 kilometers long. It is also lumpy, also cratered, also not beautiful in any conventional sense. But it is doing its work, every orbit, patiently, without awareness. The F-ring exists because of these two moons. Without them, the F-ring material would spread into a faint torus and lose its character. With them, it is kept together, kept narrow, kept braided and clumped and dynamic. Two lumpy potato-shaped rocks, orbiting Saturn, keeping a ring in existence. There are also the ring moons, the tiny bodies embedded within or just adjacent to the ring material. So small, they were not discovered until Voyager flew through the system. Pan, in the Encke gap, we mentioned. Atlas, at the outer edge of the A-ring, we mentioned. There is also Daphnis, in the Keeler gap, which is one of the more visually extraordinary small moons in the solar system. Daphnis is tiny, about 8 kilometers across, smaller than a mid-sized city, and it orbits in the narrow Keeler gap within the A-ring, and as it orbits, the ring edges on either side of it respond to its gravity. They are pulled slightly upward and downward as Daphnis passes, raising waves in the ring that stands several kilometers above the ring plane. The same kind of vertical structures we mentioned at the B-ring edge. Cassini imaged these waves at different times and from different angles. In one famous image, taken when the sun was low relative to the ring plane and shadows were long, you can see the waves as actual shadows. The crests of the waves, ice ridges a kilometer or two tall, casting their shadows across the flat ring surface below. And in the center of the gap, tiny Daphnis, no more than a grey dot, moving through the emptiness it has made for itself. The image looks like a rough sea, frozen in time. The gap is the calm before a swell, and on either side of it, the ocean of ice particles rises and falls in waves caused by something 8 kilometers across. 8 kilometers. The distance from here to the edge of town, maybe. The distance you drive to get groceries, roughly. That is the size of the body that raises kilometer-tall waves in a ring of ice around Saturn. There is a thing that happens in the rings near Saturn's equinox that is called thermal behavior, and it is subtle but worth mentioning because it speaks to something about how alive the ring system is, how much is happening within it that is invisible from the outside. Saturn's equinox, when the sun is directly over the equator and the rings are edge-on to the sun, happens about every 15 Earth years. At equinox, the sunlight hits the rings from the side rather than from above or below. The usual thermal state of the rings is disrupted. The particles that are normally in shadow for part of each orbit, or normally in direct sunlight for part of each orbit, suddenly find themselves in a different relationship with the sun. The temperature of the particles changes. The slightly warmer particles on one side of the ring, the side that has been in sunlight, are now in the same thermal state as the cooler particles on the other side. This sounds mundane, but the temperature of the ice particles affects how they interact with the charged particle environment, affects the electrostatic forces between particles, affects the density waves propagating through the ring material. And the spokes in the B-ring, which are driven by electrostatic effects, are more prominent at equinox than at other times. Cassini observed this. The spokes get more visible, more frequent around equinox, and then gradually become less prominent as the seasons progress. The rings have seasons. They respond to the angle of sunlight. They change, subtly, across Saturn's 29-year orbital period around the Sun. What you would see in the rings, looking at them from outside when Saturn is near equinox, is slightly different from what you would see when Saturn is at solstice, its northern or southern pole tipped toward the Sun. The rings are dynamic, even on these 15-year timescales. They are not frozen. They are living, if you can call a collection of ice particles living, which you probably cannot. But the word gets at something about the quality of constant change, of response to environment, of behavior that is not random but patterned. Let's come back to the silence for a moment, because the silence of the rings is one of the most real things about them, and it is easy to pass over quickly and not stay with it long enough for it to mean anything. The rings produce no sound. Nothing in the rings produces sound. Sound requires a medium, and the ring environment has no continuous medium. Between the ring particles there is essentially nothing. The densest parts of the B ring have maybe a few hundred particles per cubic meter. Compare that to the air you are breathing, which has roughly 3 times 10 to the 25th power molecules per cubic meter. The rings are emptier than the best vacuum you can create in a laboratory on Earth. A pressure wave, which is what sound is, cannot propagate through that environment. There is nothing for it to push against. You could fire a cannon inside the rings, and the cannonball would fly in silence. You could detonate an explosion, and no sound would come from it. Particles would be scattered by the blast wave if the explosion were close enough, but beyond the reach of the physical disturbance, there would be no sound. The rings are silent in a way that is absolute and unrelenting and complete. And they have been this silent since they formed. However many hundreds of millions of years ago the rings appeared, they have been silent. The particles have been orbiting in silence. The occasional slow-speed collisions between particles have happened in silence. The gravitational waves from the moons have propagated through the ring material in silence. The shepherd moons have pulled their streamers and carved their channels in silence. All of it, every event, every structure, every wave and gap and ringlet, formed and maintained and changing in absolute silence for hundreds of millions of years. And if you were there, floating in the middle of it, you would hear nothing. You would see everything. The particles around you, the glow of Saturn below, the dim stars above, the shepherd moons as tiny moving points of light in the ring plane. All of it visible, none of it audible. The only sound would be your own breathing inside your helmet, your own heartbeat. Only sounds in that environment that came from somewhere other than the eternal silence of the rings would be you. And then, eventually, you would leave, and the silence would close behind you, as if you had never been there. NASA has done data sonification of the rings, as we mentioned, turning measurements into sound. But there is another kind of ring sound that people have recorded, which is the natural radio emissions from Saturn's magnetosphere, called Saturn kilometric radiation, SKR. Saturn, like the other giant planets, generates powerful radio waves from the interaction between its magnetic field and the solar wind. These are not sound waves. They are electromagnetic radiation in the radio frequency range. But if you take those radio frequencies and shift them down into the range of human hearing, something remarkable happens. They sound like whooshes, like wind, like eerie, shifting tones that move up and down in frequency, rising and falling, surging and fading. They sound haunted, though that is exactly the wrong word, because they are a natural physical phenomenon with no feeling behind them. They sound, if anything, like what you might imagine a ghost sounds like, if ghosts were real and were made of electricity rather than memory. And Saturn's rings are moving through this radiation environment. The ring particles are embedded in Saturn's magnetic field. The charged particles in the ring material respond to that field. The radio emissions propagate through and around the ring plane. The electromagnetic environment of the rings is complex, layered, active. And if you could hear the radio frequencies, if you could stand in the ring plane and somehow tune your ears to the wavelengths of Saturn's radio emissions, you would hear something like a distant, shifting wind. A sound that has no source you could point to, that comes from everywhere and nowhere, that rises and falls without rhythm. Not the silence of the rings, something else, something around the silence. The silence is still there, absolute, inside all of it. The ice particles still colliding with no noise, still orbiting with no noise, still catching the light and tumbling and existing in the same complete, total quiet that they have always existed in. But in the electromagnetic dimension, the dimension that is invisible to human senses without instruments, something is moving, something is sounding. Saturn is humming, in the only frequencies it knows how to use. Let us think about what it would mean to have grown up knowing that. People alive before the space age, before Voyager, before Cassini, they knew Saturn had rings. Huygens had told them in 1655, but they did not know the rings in the way we know them now. They did not know about the shepherd moons, the spokes, the density waves, the ring rain, the equinoctial seasons in the ice. They did not know that the rings might be younger than the dinosaurs, that they might be gone in 100 million years, that Enceladus is feeding the E-ring with its geysers right now. They knew there were rings around Saturn. We know the rings. That is a different thing. And what is interesting is that knowing them does not make them less extraordinary. It makes them more. Every new detail, every revealed structure, every explained phenomenon is not a reduction of the mystery, but an addition to it, because each answer opens new questions, and each explained mechanism reveals a new unexplained fact sitting just behind it. The Cassini division. Explained. Clear. The resonance with Mimas, the orbital mechanics, the math is solid. Why the B ring is so much denser than the C ring right next to it, not fully understood. The spokes in the B ring, mechanism partially understood, full behavior not yet resolved. Why the ring magnetic field is so perfectly aligned, actively debated. The age of the rings, narrowed but not pinned down, probably young. How young exactly, uncertain. Where the ring material originally came from, the leading theories are compelling but not proven. The rings are a 280,000 kilometer wide object in the solar system that we have studied for 13 years with an extremely sophisticated spacecraft, and we still do not know exactly how old they are or exactly where they came from. Which is wonderful. Not in a frustrated way, in a genuine way. The mystery is a feature. It means there is more to know. It means the rings have not been exhausted. It means that whenever the next mission reaches Saturn, there will be new things to learn, new questions to ask, new structures to understand. The rings are not done teaching. The density waves that spiral through the rings are one of the more meditative structures in the solar system, if you let yourself think about them long enough. Here is what happens. A moon orbits outside the rings. Let's say it is Mimas, though many moons create density waves in the rings. Mimas orbits Saturn at a certain distance, and at a certain fraction of that distance, inside the rings, particles orbit at a resonant ratio with Mimas. Maybe 2 to 1, maybe 3 to 2, maybe 4 to 3. Every time those ring particles come back to a certain point in their orbit, Mimas is close. The gravitational nudge happens. It is tiny, far too small to measure with human senses, but the physics records it. The particle's orbit changes, microscopically. This happens again on the next orbit, and the next, and the next. Each nudge in the same direction at the same orbital phase, accumulating. And eventually, the accumulated effect is visible. The particles at the resonant radius start to cluster slightly, to pile up on one side of their orbits, to create a slightly higher density on one side than the other. And because they are orbiting, because the pattern rotates, and because the inner particles orbit faster than the outer ones, the density pattern spirals outward. A spiral density wave. It looks, in Cassini's images, like the grooves in a vinyl record, or like the structure of a galaxy arm. The same mathematics, operating at radically different scales. A moon and a ring creating a spiral pattern. Gravity and time creating structure from what was otherwise uniform. And the spiral propagates outward, slowly damping, losing amplitude, the wave spreading its energy across more and more particles until eventually it fades and the ring returns to uniformity. Then, a new resonance generates a new wave. The ring is, in this sense, constantly being written, constantly receiving messages from the moons in the form of gravitational pulses, and translating those pulses into structural patterns that propagate and fade and propagate again. A ring as a kind of medium, a ring as a receiver, all in silence. Something worth noting, because it is one of those facts that arrives quietly and then stays with you, is that the rings are not flat in the way we usually picture them. Yes, they are extraordinarily thin relative to their width, paper thin when scaled down. But they are not a perfect plane. They have vertical structure. The density waves, the edge waves, the structures created by shepherd moons, all of these involve ring material moving above and below the nominal ring plane. And the ring particles themselves are not all moving in exactly the same plane. Their orbits are inclined by tiny amounts to each other, so that the ring has a thickness that is the result of many orbits, each slightly tilted, each intersecting the nominal plane at slightly different angles. This thickness, small as it is why you can see the rings from above and below. If the rings were truly a perfect two-dimensional plane, infinitely thin, you would not be able to see them from any angle other than exactly edge-on. They have some extent in the vertical direction, some thickness, and it is that thickness that makes them visible from above and below. The B-ring, in its thickest parts, might be 100 meters to 1 kilometer thick. That is its vertical extent. And within that vertical extent, billions of particles are orbiting on their slightly tilted, slightly different paths, each one cutting across the nominal plane, spending time above it and below it, never perfectly in the plane, but always crossing through it. The ring is not a disk. It is a swarm of particles, most of them in orbits so close to the plane that from any distance at all, it looks like a disk. But up close, inside, you are surrounded in 3 dimensions by particles, not standing on a flat surface. You are inside the swarm. And the swarm moves around you, patient and slow. The equatorial ridge on Pan. We mentioned it briefly, this feature that gives Pan its flying saucer shape, but it deserves more attention because it is one of the more elegant demonstrations of how the ring environment works. Pan is a small moon, about 28 kilometers long, orbiting inside the Encke gap in the A-ring. It keeps the gap clear, as we said, sweeping up or gravitationally scattering any material that tries to drift into the gap. But Pan itself is not just clearing the gap, it is also accumulating material. Ring particles at the edges of the gap, the ones that come close to Pan on each orbit, some of them do not escape. Some of them are moving slowly enough, relative to Pan, that Pan's gravity captures them. they fall onto Pan. But they do not fall uniformly. They fall preferentially at Pan's equator because of the geometry of the orbital dynamics, because the ring plane is aligned with Pan's equatorial plane, because the material coming in from the ring edges approaches at a low angle and deposits on the equatorial regions. And over millions of years, this preferential deposition builds up. More material accretes at the equator than at the poles. The equatorial regions grow thicker, accumulate more mass, build up into a ridge. The ridge is made of ring material. It is a ring particle accumulation on the Moon. Pan is wearing a ring. And the ring material accreted on Pan has its own character, different from Pan's original body. It is probably fluffier, less dense, more like loosely packed snow than the solid interior of Pan. The images Cassini took of Pan show the ridge as slightly brighter than the rest of the Moon, or at least differently textured. A moon built its own ring structure, attached to itself, accreted from the ring it lives inside. Everything in the Saturn system is in conversation with everything else. The rings shaping the moons shaping the rings, the planet shaping both. Everything connected by gravity and time into a system that is constantly, silently negotiating its own structure. There is a phenomenon in the rings called self-gravity wakes. This is a gravitational instability that occurs when the ring particles are dense enough that they begin to influence each other's orbits, not just responding to Saturn and the moons, but to each other. When the particle density gets high enough, the particles begin to clump together under their own mutual gravity, forming elongated structures called self-gravity wakes, which are not permanent clumps, but more like dynamic, temporary aggregations that form and dissipate continuously. They are elongated along the direction of orbital motion because the shear forces in the ring, the fact that inner particles orbit faster and outer particles orbit slower, tend to pull any clump out into an elongated shape before it can round itself into a sphere. So the dense parts of the rings are not just a random sea of particles. They are a sea of particles that is continuously clumping and shearing, forming transient aggregates and pulling them apart, never quite achieving a stable structure, but always trying, always responding to the mutual gravity that wants to bring particles together. The rings are almost alive in this mechanical sense. Not static, not just passive particles following their assigned orbits. Active, responding, structuring themselves. This self-gravity behavior is important for understanding the mass of the rings. When you try to measure the ring mass by looking at how much the rings deflect a spacecraft's trajectory or how much they distort the orbits of nearby moons, the result depends on the actual distribution of mass within the ring, including the mass hidden in these self-gravity wakes. Cassini's grand finale provided new measurements of the ring mass by measuring the gravity field between the rings and Saturn directly, from inside that gap. The result was surprising. The rings are less massive than many models predicted, significantly less massive. The total mass of the main rings is about half the mass of Mimas, the moon that maintains the Cassini division. Half the mass of Mimas, which is small for something 280,000 kilometers wide. This relatively low mass is part of what supports the young rings hypothesis. If the rings were billions of years old, they would have accreted more mass from incoming comets and dust over that time. They would be heavier. The fact that they are not so heavy suggests they have not been collecting debris for as long as an old ring system would have. Young rings, light rings, bright, pure, thin, light, young, moving in silence through the outer solar system as if they just arrived. What would it mean to be the last person to see the rings? Not the last person to know about them. Not the last scientist to analyze Cassini data. But the last person to look up at Saturn with a telescope and see the rings after they have faded, after they have drained and spread and lost their brightness. In 100 million years, or 300 million years, or whatever the final number turns out to be, some being, some creature that may or may not be descended from anything alive today, may look towards Saturn with whatever instrument of observation they have, and the rings will be thinner, dimmer, perhaps barely there. A faint haze around the planet, a ghost of what they were, and eventually, nothing, just Saturn, a gas giant, spectacular in its own right, banded and enormous, but without the rings, just a planet. And if that being knows the history, if they have the records, if they have the images from Cassini and from the Hubble Space Telescope, and from all the other instruments that have ever looked at Saturn, they will know what was there before. They will know what the rings were. They will have seen photographs of them, the way we have seen photographs of species that no longer exist, the thylacine, the dodo, with a faint ache of having missed them. We are not missing them. We are alive right now. The rings are there right now, tonight, as they have been for the whole of human history and before, unchanged in any time scale we can perceive, and they will be there tomorrow night, and next year, and 1,000 years from now, but not forever. They are borrowing time in the cosmic sense, and so are we, and that is not a sad thought. It is, in the right mood, at the right hour, a kind of quiet gift. To be here when the rings are here. To be the kind of creatures who can look up and notice them. To have sent a spacecraft that spent 13 years in orbit around Saturn and came back with photographs and measurements and answers and new questions, and finally gave itself to the planet. We are lucky. In the specific, concrete, measurable sense of having been born at a time when Saturn still has rings, in a universe that produced anything as strange and beautiful and silent as Saturn's rings at all. The temperature in the rings, on average, is around -185 degrees Celsius. That is cold in a way that is almost impossible to feel from inside a warm room, inside the atmosphere of a planet that sits close enough to the sun to sustain liquid water on its surface. 185 degrees below 0 Celsius. 87 degrees above absolute zero, the theoretical temperature at which all molecular motion would stop. The ring particles are cold in the way that space is cold, in the way that the outer solar system is cold, in a way that makes the cold of a winter night on Earth feel like standing in front of a fireplace. At that temperature, the ice is not fragile. It is hard. Harder than room temperature ice, more crystalline, less prone to creep and flow. It has been that cold for hundreds of millions of years, possibly. The ring particles have never been warm. They were formed in the outer solar system, far from the sun, and they have never traveled inward. Some of the particles in the rings have not been touched by anything in millions of years. No collision, no close approach to another particle, no exposure to anything except the dim sunlight and the particle radiation environment of the outer solar system. Just orbiting, just existing, cold and unchanged. A particle of ice, alone, unchanged for 1,000,000 years, moving through the dark in perfect silence, with no awareness of its own extraordinary patience. Right now, tonight, out there, while you accumulating in Titan's orbit or being swept up by the moons. The E-ring is the most transparent of all the rings to light, the most diffuse, more cloud than ring. If you were to drift through it, you would barely know you were in a ring at all. Just the faintest, barely perceptible haziness in the middle distance, a softening of the stars ahead of you, a suggestion of structure that resolves into nothing when you try to look at it directly. And somewhere inside that haze, a particle of ice that left Enceladus's geysers perhaps a year ago, perhaps a decade ago, is drifting in its orbit. Fresh ice, recently erupted, possibly, if the speculation about Enceladus's ocean is correct, ice from water that has never seen sunlight, that has existed in liquid form in the dark interior of a small moon, and then was heated and erupted and frozen in the vacuum of space, and is now orbiting Saturn in a ring so faint it is almost invisible. There is a whole world hidden under Enceladus's ice, and that world is feeding the rings, right now. The temperature of the ring particles, negative 185 degrees Celsius, is a number that rewards sitting with. Not cold in the way that a freezer is cold, or even the way that a winter night in a northern place is cold. Cold in the way that the outer solar system is cold, which is a different category of cold entirely. A cold that is the natural state of matter at this distance from the Sun. The Sun, from Saturn's distance, provides about 1% of the energy it provides to Earth. Less than 1%. The warmth that reaches the rings is so faint that it barely registers as warmth. And yet it is not zero. The rings are not at absolute zero. There is still some energy there. The particles are still vibrating, still rotating, still absorbing and re-emitting the tiny amounts of radiation that reach them. They are cold, but they are alive in the thermodynamic sense. Not inert. Not frozen in place in every sense. Just cold. And in that cold, perfectly stable, perfectly preserved, the ice that makes the rings is unchanged across millions of years of orbiting. There is no weathering, no erosion in the terrestrial sense. The particles are shaped by collisions when they happen, and by the slow accumulation of micrometeorite dust that darkens their surfaces, but otherwise they are the same particles they have always been. Ancient ice, cold and patient, moving through the dark in absolute silence at several kilometers per second, 1 billion miles from where you are lying right now in this room, this warm room. The rings have seasons. We touched on this briefly, and it is worth returning to, because it is one of the stranger and more quietly beautiful things about the ring system. The idea that this vast, silent structure responds to the tilt of Saturn's axis, to the angle at which the sunlight arrives. Saturn's axial tilt is about 26.7 degrees, similar to Earth's 23.4 degrees, which means Saturn has seasons, proper seasons, summer and winter and equinox and solstice, just as Earth does. Except Saturn's year is 29.5 Earth years long. So each of Saturn's seasons lasts about 7.5 Earth years. At Saturn's northern solstice, the North Pole is tipped toward the Sun. The northern half of Saturn receives more sunlight. The rings, seen from Earth, are tilted with their north face toward us. The shadow of Saturn falls on the rings differently. The shadow of the rings falls on Saturn differently. At equinox, the rings are edge-on to the Sun. The sunlight hits the ring plane from the side. The rings cast almost no shadow on Saturn. The vertical structures in the ring edges, the 2-kilometer-tall wave mountains at the edges of the B ring, catch the sunlight and cast enormous shadows across the ring plane because the Sun is almost exactly horizontal to the ring plane and the shadows are very long. And the spokes appear. More spokes, more frequently. The B ring's strange radial features, driven by electrostatic forces that are enhanced at equinox when the thermal conditions of the ring particles change, becoming more prominent, more visible, appearing and fading and appearing again. The last Saturn equinox before Cassini's mission ended happened in August 2009, about 8 years into the mission. Cassini was there for it. Cassini watched the rings change, watched the spokes intensify, watched the shadow geometry shift. The next Saturn equinox will be in 2025. We have no spacecraft at Saturn to observe it. The rings will go through their equinoctial changes. Spokes will intensify, the shadows will lengthen, the vertical structures will catch the sideways sunlight, and none of it will be imaged by anything human-made. It will happen as it has always happened, unobserved, unremarked upon, in the silence and the cold. And then the season will turn, and the rings will return to their more familiar appearance, and that equinox will be gone. The way all things eventually pass, quietly and without announcement. There is a planned mission to return to Saturn. NASA and ESA have been discussing and developing concepts for a follow-up to Cassini. The Dragonfly mission will go to Titan. There are concepts for an Enceladus orbiter, a mission specifically designed to fly through the plumes and study the ocean chemistry in detail, to answer the question of whether there is life in the water under the ice. And there are concepts for a Saturn ring mission, a dedicated ring observer that would do for the rings what Cassini did across its whole mission, but focused on a smaller area, staying close to the rings, studying the structures and the dynamics and the age question in the detail that even Cassini could not fully achieve. These missions are not funded yet, not fully designed. They exist as proposals and concepts and scientific priorities, waiting for budget and will and time. But they will happen, eventually. The scientific community's interest in Saturn has not faded. Cassini's answers and the new questions those answers raised have ensured that. Some person alive right now, working in some university or research institution, is helping to design that future mission, helping to write the science case for it, helping to specify what instruments should fly, what questions they should ask, what data they should gather. That person has not seen Saturn up close. They are working from Cassini's data, from the photographs and measurements, and they are planning to go back. And the rings, right now, tonight, are there waiting, not knowing about the plans, not knowing about the Cassini data being analyzed, not knowing about anything, just orbiting, just being the rings, exactly what they have always been. Let me stay with the silence once more for a while. The silence of the rings is not the same as quiet. Quiet is a relative thing. Quiet is what a room sounds like at 3 in the morning when the traffic has stopped and the house has settled and the only sounds are small and distant. Quiet is not the absence of sound, just the diminishment of it. The rings are not quiet. They are silent. The distinction is absolute. Quiet is a degree of sound. Silence in the rings is the absence of the medium through which sound could travel at all. It is not that there are no sounds to hear. It is that the concept of sound, the physical mechanism by which pressure waves carry information from a source to a receiver, simply does not apply there. You cannot be quiet in the rings. You are not the silence. There is no contrast between you and the silence, because the silence is not a state the environment has settled into. It is the nature of the environment. It is what the environment is. The first human being to stand in the rings, in whatever future century that happens, if it ever does, will experience this. They will move and hear their suit. They will breathe and hear their breath. They will hear their heartbeat, amplified by the closed environment of their helmet, regular and steady, the only acoustic event in an otherwise absolutely silent universe at that moment. And if they were to hold very still and slow their breath and be as quiet as a human being can be, the silence outside their suit would be the silence that has existed in those rings since before their planet formed. Longer, possibly, than any sound anywhere on Earth. That silence has continuity. It has history. It is not a new silence, a recent one, a silence that arrived when the last sound stopped. It is a silence that has never been broken, that cannot be broken, because sound cannot exist there. And the first person to stand in the rings will be inside that silence and unable to touch it, which seems right. The rings are changing right now, not in a way you could see in a human lifetime, not in a way that would be visible on any time scale that feels real to us. But they are changing. Changing the way mountains change, the way coastlines change, the way slow things change, on their own terms, at their own unhurried pace. Ring. Rain. Every second. The charged particles flowing down Saturn's magnetic field lines, pulled by the electromagnetic forces that connect the ring plane to the planet's upper atmosphere, falling through the gap between the D-ring and the cloud tops that Cassini flew through 22 times in its final year. Right now, as you lie here, ring material is falling into Saturn. Not much, not enough to see, not enough to notice in a human lifetime or 100 human lifetimes, but falling. The rings are becoming Saturn. The particles that leave the rings become part of Saturn's atmosphere, are absorbed into the cloud layers, their water molecules broken apart by the chemistry of the upper atmosphere, their oxygen and hydrogen distributed through the gas layers. In some sense, the material of the rings is not being lost. It is being returned. Returned to the planet that, in some versions of the formation theory, shed it originally, when a moon was broken apart or a comet was torn by tidal forces. The rings are coming home, slowly, silently, at a rate of hundreds of kilograms per second, over hundreds of millions of years. And what is left behind, what is still there tonight, what will be there for your entire lifetime and the lifetimes of everyone you will ever know and everyone they will ever know, is still extraordinary, still bright, still orbiting, still the most immediately beautiful thing in the solar system, still here. The self-gravity wakes in the dense parts of the rings, those transient clumps of particles gathering under their own mutual gravity, and then being torn apart by orbital shear before they can become anything permanent. Those are happening right now too. In the B-ring, in the densest regions, particles are clustering together for a few hours, a few orbits, building up a small aggregation of ice, a temporary body. And then the differential orbital speeds are pulling it apart again, the inner particles moving faster than the outer particles, stretching the clump into an elongated strand, and then dissolving it back into the general population of independent orbiting particles. Forming and dissolving, forming and dissolving. The ring is always almost making something, always almost becoming moons, becoming solid objects, becoming bodies with names and orbits and histories, but always stopping short, always being pulled apart before the process completes. It is as if the rings are practicing, learning how to become something more substantial, getting almost there and then losing it and starting again. This is, in a very real sense, what the early solar system looked like. The disk of gas and dust around the young sun, 4.5 billion years ago, had these same dynamics. Clumps forming and dissolving, particles aggregating and being torn apart. And then, gradually, in some places, the clumps becoming large enough that their own gravity was stronger than the tidal forces trying to pull them apart. And those clumps grew, and became planetesimals, and became planets. Saturn's rings are running a version of that process, but losing. The rings are too close to Saturn, too deep inside the tidal forces, for the self-gravity wakes to ever win. They will never become moons. They will always be pulled apart before they can consolidate. Except at the edges. At the outer edges of the rings, where the tidal forces from Saturn are weaker, there are small moons. The very small moons, the ones just outside the A-ring, the ones that maintain the ring edges, they are the product of ring material that managed to accumulate at a location where Saturn's tidal forces were just barely weak enough to let gravity win. The shepherd moons are the ring's success stories. The rings that could not become moons became the material for moons that stand just outside the rings and keep them in shape. The rings made their own shepherds. We should talk about what Saturn itself looks like from the rings, one more time, because I am not sure the earlier description quite captured it. Saturn is not just large from the ring plane. It is present in the way that a nearby landscape is present, not a feature in the sky, but an environment. When you look at the moon from Earth, you are looking at something in the sky, something separate, something out there. From within the rings, you are not looking at Saturn in that way. Saturn is below you and around you, and the context of everything you are experiencing. The cloud bands are visible even from the distance of the middle A-ring. The pale yellows and the off-whites and the subtle ambers. The bands are not crisp, they are soft at their edges, diffusing into each other, the wind systems at their boundaries creating the slight haziness that blends one band into the next. The great hexagonal storm at Saturn's North Pole is not visible from the ring plane, not the right angle. But at the right orbital position, the right geometry, other storm structures in the atmosphere are visible. Oval features, darker spots. The turbulence at the edges of the wind bands, all of it immense, all of it below you. Moving, because Saturn rotates every 10.5 hours, and you can see the rotation if you watch long enough, the bands sweeping slowly under you. And you are also moving, orbiting Saturn in your position in the rings, moving around the planet in your own orbital period, which, in the middle of the A-ring, is about 14 hours or so. So Saturn is rotating slightly faster than you are orbiting, and the planet below you appears to rotate slowly, the features drifting, the bands shifting position. You are watching a world turn. From very close, in complete silence. And around you, the ice particles drifting, catching the light, the nearest ones floating in easy view, the farther ones merging into a faintly glowing haze toward the edges of your vision. And above, through the haze of scattered ring light, the stars. Dimmer than they would be from open space, but there. The same stars that are visible from Earth tonight, from wherever you are lying, though from the rings they are dimmer and the patterns are shifted by the viewing angle. The same stars, the same universe, just a very different place to be standing in it. The particles in the rings that are the size of a house are worth thinking about specifically. There are not many of them. They are rare, but they exist. Scattered through the main rings, large chunks of ice that have been there for however long the rings have existed, slowly having their surfaces chipped and worn by micrometeorite impacts, slowly accumulating the dark organic coating that comes from long exposure to the space environment, but still there, still orbiting. A house-sized chunk of ice in the B ring. It has its own gravity. Not enough to be spherical, not enough to be called a moon, but enough to have a slight gravitational influence on the particles that orbit near it. Enough, perhaps, to have accumulated a small pile of finer material on its surface, a thin layer of dust settled onto it over millions of years of slow accumulation. If you were to approach it, float up to it, reach out and touch it, the ice would be extremely cold and extremely hard. Not the ice you get from a freezer, which is at -18 degrees Celsius, and still somewhat plastic, somewhat yielding. This ice is at -185 degrees, and it has been that cold for millions of years, and it is dense and crystalline in the way that very cold ice is, more like rock than like what you think of as ice. You could stand on it. A small surface, maybe 10 meters across, maybe 20. You could stand on it and look around you. Ring particles in every direction, at varying distances. Saturn below and around you. The light scattered by the billions of particles between you and the sun, creating a soft ambient glow. You would be standing on a piece of ice that has been orbiting Saturn since before the first dinosaur. And it would not know you were there. And when you left, it would continue its orbit exactly as it had been orbiting before you arrived. Unchanged, patient, in the same path it has kept for millions of years. The rings are like that. They receive everything and register nothing. They orbit regardless. And there is something about that indifference that is, at this hour, at this moment, as the room gets quieter and the night gets deeper, not cold or alienating, but deeply, strangely peaceful. The rings do not need you to be there. They do not need to be observed. They do not need to be understood. They do not need to mean anything. They simply are. And they have been. And they will be, long after everything in this room, everything in this city, everything we have built and named and worried about has returned to the elements it came from. The rings will be orbiting. Long after that, still. Tonight. Right now. While you are here in this room, breathing slowly, the day already fading, the thoughts getting quieter and less urgent, less shaped. Prometheus is somewhere in its orbit around Saturn. It is not a large moon, not dramatic. A lumpy, potato-shaped thing, maybe 80 kilometers at its widest. But it is moving. It is always moving, completing an orbit every 14.7 hours, and somewhere in that orbit right now, it is approaching the F ring, or drawing away from it, or pulling a slow channel through the bright ring material, that dark line opening up in the ice, and then, slowly, over the next several orbits, filling back in. It does not know it is doing this. It does not know about the ring. It does not know about the 19-day cycle. It has no knowledge of itself. It just orbits. And the ring responds, and has been responding since before the first human eye looked up at night and wondered what the lights in the sky were. And Pandora is there too, on the other side of the F ring, keeping the outer edge shaped, and between them the F ring exists, narrow and dynamic and braided, the most restless part of the ring system, the part that changes on timescales of days and weeks, changing right now, tonight. And the shepherd moons of the other rings are there, Atlas at the outer edge of the A ring, Pan in its gap, Daphnis in its smaller gap, raising waves in the gap edges that nobody is watching. All of them orbiting, all of them doing their slow, patient work on the rings around them. In the silence, in the cold, 1 billion miles from where you are. There is a distance between here and there that is, in one sense, incomprehensible. 1 billion miles. Light takes 83 minutes to cross it. The fastest spacecraft ever built would take years. The distance is real and absolute, and in purely practical terms, it might as well be infinite, because you will not cross it in this lifetime, and neither will anyone you know. And in another sense, the distance is nothing. You are thinking about the rings right now. You are, in some meaningful sense, there. Not physically, not in any way that affects the rings or changes what they are doing or makes them aware of your attention. But your mind is there. Your imagination is floating through the ring plane, and the rings are real, and the gap between you is just space, just distance. And distance is not the same as absence. The rings are not absent from your life because they are 1 billion miles away. They are present. They are present in the photographs that Cassini took and that you have seen. They are present in the data that scientists analyzed and published, and that became part of our understanding of the solar system. They are present in the fact that Saturn is out there right now, if you were to go outside and know where to look, a steady, yellowish point of light in the night sky. The rings too small to see, but there, always there, going about their business. They are present right now in this room, in this particular way, in the fact that you are thinking about them. The ice particles don't know. They will never know. But you know. And that is its own kind of thing. The rings will not last forever. We said this before, and it is worth returning to one final time. Not as a sad thought, but as the specific, concrete shape of why tonight matters. In 100 million years, the rings will be diminished. In 300 million years, possibly gone. Saturn will still be there, vast and banded and extraordinary in its own right. But the rings will have drained away into the planet, and the gas giant that remains will be unremarkable in the specific way the rings make remarkable. Any being that exists then, looking towards Saturn, will see a planet. Any being that exists now, looking towards Saturn, sees the rings. We are the ones who get to see the rings. This generation, these years, this particular moment in the history of the solar system, which is itself a tiny fraction of the history of the universe, which is itself a tiny fraction of whatever the universe will eventually become. We are in the window. The rings are here. And they are exactly as they have always been, as extraordinary as they have always been, as silent and patient and beautiful as they have always been. And they will be there tomorrow and next year and 1,000 years from now. But not forever. And that is the gift, if there is one. Not the permanence of the rings, the temporariness, the fact that right now, tonight, they are there. Let them be there. Let them orbit in the silence that has never been broken. Let Prometheus do its slow work on the F ring. Let the density waves spiral through the B ring. Let Daphnis raise its waves in the Keeler gap with no one watching. Let the ring rain fall, silently, down the magnetic field lines into Saturn's cloud tops. Let the temperature stay at 185 below. Let the ice stay hard and old and cold. Let the particles keep the orbits they have kept for millions of years. Let it all continue exactly as it has been continuing. And you are warm. You are still. The room is quiet in the way rooms get quiet very late, when the sounds of the day have fully retreated and what is left is the small sounds of a house at rest. The rings are out there, and you are here. And the distance between those two things is just space. Just cold, empty space, filled with nothing but silence and light. Somewhere out there, right now, a single particle of ice. Not one of the house-sized ones, not one of the boulder-sized ones, a small one, maybe the size of a marble, maybe smaller. In the B ring, maybe, among billions of others, or maybe in the outer edge of the A ring, or maybe drifting in the faint haze of the C ring. It has an orbit. It has kept that orbit, more or less, for millions of years. It does not know this. It just orbits. Cold, patient. in the silence that has never been broken. Nobody is watching it. No spacecraft. No telescope powerful enough to resolve it from Earth. No instrument of any kind. It orbits anyway. It has always orbited anyway. And somewhere, in the deep cold and the dark, that particle of ice is catching the dim light of a distant sun and scattering it, just slightly, into the space around it. A tiny contribution to the overall brightness of the rings. One particle, among billions. Each one alone, each one in its own orbit. Each one silent, cold, patient, unchanged, still orbiting, still. Good night.